up and down, alternating from about minus 90 and minus 20 grams as it goes up and down. A little more power. All negative. It jumps up and down. It is difficult to get any upward force out of a fast spinning magnet, as I will show you directly. Here's a crop picture from 2018, which is the basis for the model we're building today. You can see there's a wire coil here, a ring electromagnet, and that's this thing. 3 other wire coils, 1, 2, 3, and that's those 3 things. And in the center we have a magnet which is rising up and spinning, which this will do when I add 3-phase power. Now when it does so, we're going to watch to see how much the weight changes on the scale. See, the magnet at low power begins to wobble. The scale's balanced, nothing's happening. A little higher power, nothing's happening on the scale. Now the magnet's spinning quite nicely. Nothing's happening on the scale. Go up to about 20 Hertz. Now the magnet's spinning very rapidly. Nothing's happening on the scale. So this magnet with 3-phase power does not lift up very easily. First experiments will use the 70mm magnet with a fairly small 14mm hole in the middle, which is almost the size of the 8mm rod on which it is spinning. Next we're going to test a different kind of magnet, 60mm diameter, 20mm hole in the middle, and it will spin lopsided, and that will generate quite a large upward force. Now when using this 60mm magnet with a big 20mm hole in the middle, we turn on the 3-phase power, and you can see it spinning very lopsided, off axis, at low power, because of the hole. And as we go to slightly higher power, it goes up. Keep going. There's still no change of weight on the scale. But if we go to even higher power, like this, it'll jump up and down. And that causes big changes to weight on the scale. Up, down, up, down, up, down. The up force doesn't generate any weight, but the down force generates a lot of free fall weight. You can see the scale moving quite radically now. Studies today have been based on this crop picture from 2018, which has at its bottom a ring electromagnet, which is this thing here, which I haven't actually turned on yet. Three-phase wire coils, which are obviously those three things. 1, 2, 3, 1, 2, 3, and in the center a spinning magnet, which is placed there. Now I've tried several magnets. The most interesting one is this 60mm magnet with a 20mm hole in the middle. And when you place it there, it goes up and down like a gravitational capacitor, storing gravitational potential energy and then releasing it in maybe 1-second cycles. That's quite interesting as a potential new way to do space travel. In the next part of this video, we'll quantify those motions using a digital scale. Up and down, alternating from about -90 and -20 grams as it goes up and down. A little more power. All negative. It jumps up and down.